sediments acquired from Antarctica reveals 1 million-year-old DNA. Using sediments acquired during Expedition 382, scientists have discovered ancient DNA dating back 1 million years. Understanding the past climate of our planet is of great importance if we are to understand how natural climatological cycles will occur in the future of our planet. But in addition to that, it is also important to know how external factors affected the climate, ice, and sea level in the past. Therefore, in order to see what Earth was like in the distant past, even millions of years ago, we look to the massive ice sheets our planet is home to. Using deep-sea sediments in the Scotia Sea north of the Antarctic continent, scientists from the University of Tasmania and the University of Bonn have discovered the oldest marine DNA yet discovered. As per scientists, there is evidence that the material previously recovered contains material that dates back a million years. According to the findings, sedimentary DNA demonstrates how climate change can affect ocean ecosystems for extended periods of time. As a result of this finding, the marine life around the frozen continent can also be assessed in terms of its current condition and future changes. This is particularly important given the vulnerability of our planet's largest frozen desert, Antarctica, to climate change. It is, therefore, critical and urgent to study how polar marine ecosystems have responded to environmental and climate change over time. In recent years, sedimentary ancient DNA, SEDADNA, has become an important technique for analyzing the past of the ocean, including when it lived and who lived there. Climate change can also be associated with times of major composition changes. Knowing how marine life around Antarctica will respond to climate change in the future can help us make predictions, adapt, and be prepared. Using sediments acquired during Expedition 382, Iceberg Alley and Subantarctic Ice and Ocean Dynamics in 2019, SEDADNA was used by an international team to investigate marine organism structure changes over the last 1 million years. Firstly, the team inspected the DNA fragments for signs of age-related damage, as well as for signs of contamination, and ensured that SEDADNA signals were genuine. With all precautions taken, they were able to detect ancient DNA that was 1 million years old. Lead investigator Dr. Linda Armbrecht from the University of Tasmania, Australia, said that this is by far the oldest authenticated marine SEDADNA to date. Diatoms were among the organisms whose DNA was detected to be 500,000 years old. Diatom abundance also increased during warm climate periods, according to the data. Scotia Sea's food web went through a similar change roughly 14,500 years ago. Dr. Michael Weber, the second author of the study from the University of Bonn, noted that this change is associated with rapid rises in sea levels worldwide, and massive losses of Antarctic ice due to natural warming. Antarctica's ocean productivity increased as a result of the warming. Using SEDADNA analysis of marine ecosystems over the course of multiple ice ages, the study shows that marine SEDADNA analysis can be extended to hundreds of thousands of years, enabling the study of ecosystem-wide marine shifts and changes to paleoproductivity over time. Climate change during these periods can also provide insight into how the ecosystem will respond to current and future human-induced climate change. The study detailing the discovery was published in the journal Nature Communications.